everybody, welcome to my YouTube channel. Please like, share, subscribe and comment. So today we are going to talk about compound compilation in molecular talking, or we can also call it text mining. So let's say we have a topic saying in silico identification of novel neuraminidase inhibitors. In silico, we are saying this is computational talking, and identification of novel neuraminidase inhibitors. This means that this is where we get new compounds to inhibit neuraminidase. So neuraminidase is a protein on the outer part of influenza virus. So when this protein is inhibited, the influenza virus is kept in the cell which it infects and doesn't spread throughout the body. So this is neuraminidase inhibitors from citrus lemon. So we are finding the inhibitors from citrus lemon, which is lemon in English, for influenza A H1N1 pandemic 2009. So this is for the influenza A H1N1 of the pandemic of 2009, which started in the United States. And also we have it is a bioinformatics and a computational chemistry approach. So without further ado, let's just jump into the process of the compound compilation. So first of all, we go to a database called Dr. Duke's Phytochemical database. Here it is. So we go on to the database, we click on here. Then we arrive at the database. So we want to search for in this here. This is the filtering part of it. So we are going to these biochemical, chemical, and phytochemicals and ethnobotanicals. So we are just to leave it on any of that, and then enter the search item. On our search item, we are going to write citrus lemon. So we're just going to say search, and then after that we have some results here displaying. Here it's displaying 1, 2, 3. So we want citrus lemon derivation plant, the lemon plant. So we get that, and then we get a result of the chemicals. So these are the chemicals in the fruit, in the plant. You can see there are many windows which we have for the chemicals which are in the plant, so we need to filter them. So you need chemicals which have got activity, and those which exclude unambiguous chemicals such as water or ions. And then on the plant parts, let's just focus on fruit essential oil. Next, you can take any part of the citrus lemon, but for now let's just work with fruit essential oil. So we apply the field, and then we have the results now. You can see now it's only one page. So as we have seen in our topic, our citrus lemon should be inhibiting influenza A H1N1 pandemic or not. So we want compounds which are anti-flu, anti-flu. So let's look into this first one, alpha pipine. So alpha pipine, this is the compound anti. We want to go to the results. Okay, so these are the activities of the compounds. So that's where we are looking at, and we see that it is an anti-flu, an anti-inflammatory, and antiseptic. So it is anti-flu. So we we want it. So what we will do is we copy the name to Excel. Okay, let's just take the name of by okay, so this is our number one chemical which we've seen, which we are going to try to drop to see if it's going to inhibit neuraminidase, is it is in anti-flu. Okay, so we also go to the second compound, which we look at the activities. You can see this one, anti-aggregant, anti-personal. This one is no anti-flu. So we just do that for all the commands. For now, we are just going to look for another one. Let's see which one should we take. Let's take limonene. So limonene, let's look into the properties, the activities, and it's look like, and then anti-flu, it is there. So it can also be a potential inhibitor of neuraminidase. So we also copy the name and put it in our Excel. Right. And then, and also so on this, on Dr. Duke's Phytochemical and Ethnobotanical database, we just want the names which are anti-flu. This is better than looking into the literature and trying to find out which ones are anti-flu. Here they are listed. You can just look at it. It is anti-flu. Then you select it. And so there's also something. Let's say you just want anti-flu compounds, just anti-flu compounds without specifying the plant. We just go on the anti-flu here, and then you got a series of anti-flu compounds which are from different plants, as you can see here. And you can also get some plants of that type of the different which are anti-flu. Then see this say okra, Japanese silver, fair, yeah, this all. So after taking our our names, we go to the Lotus database. So Mr. Lotus. Then we go the Lotus natural products. That's the one which we want. And then we go on and click the Lotus natural products online or go into the Lotus database. So here now we are just plugging in the names which we have obtained. Let's say let's start with lemon. Let's copy, then paste. So we have our compounds here. So we then choose we want this one, the lemon. We click here on the CID, and then we have our results. So here these are more information on the compound. What we want is the canonical smiles from the Lotus database. So we copy and we paste. Also got the alpha pinene. Also copy and we go on here. We paste so that we search in the Lotus. You see we have no results now. So when you search a compound and you see that the result is a natural product, that means the compound name in the database will be different from the one which you have entered. So you look for other names of that compound. So let's say other names for alpha piping. Then we see these names which are shown. So let's just take alpha pin here and copy, go back to our Lotus. We delete that one and we paste, and then we search, and then we see, and then you see now the result will come out. So we have got our pipings here. So we choose the one which we want. At the oxide we definitely don't want it. Then we have got the negative and the positive. In this case we want the positive, so we are going to click over here so we get more information on the compound. So here are the results. So we said we want the canonical smiles. We copy and then we paste in our Excel sheet. So we have here the canonical smiles. So we are taking only the canonical smiles in the Lotus database, because if we take the 3D structures, they won't be accepted in the PyRx software. So we just take the canonical osmosis and then we go to PubChem. PubChem database. So we select here PubChem. And then we use the canonical osmosis now to search for the compounds. Yes, alpha prenine. We copy here, then we go, then we paste, then we search. It should give us one compound. That's exact one. Because if you use the CID of the Lotus, you are going to get many compounds, but here it will give you just one compound. So here we only want this information on the compounds. But what we want, we just want the compound CID. That's the one which we want. Copy. And then we paste this here. And then we copy again the compound, the small of lemon. Then we go on to PubChem. We paste and we search to get one compound. You see one compound getting as a result just one compound. So we want the compound CID only. So copy and paste here. So the reason we are taking only the compound CIDs is that we want the compounds to be in one place so that when we upload them in PyRx or for docking, they will be just in one document. We don't talk one by one, we just talk them at once. So after this, we copy these compound CIDs. So copy and then we go back to PubChem and then we paste here and then we search. And then please choose the data collection of the identified list search. So we want the compounds. We should get two and then we get our two compounds here. The alpha by pin the positive one and then limonene. So we are going to download this one. So these are just some of the information. You see molecular formula here, molecular weight, compound CID number, then the smiles, then date created and in all other information which you will be wanting to see. And if you click further here, you see more information displayed at the place. So here we want to download the one the 3D structure. That's the one which I used in talking. Number of conformers, we only want one, and then we want it to be in STF. So we have now our documents here. Here it's showing in blue because I have a Discover Studio which opens up the file. Okay, so now we want to convert the we want to convert the STF file to a PDF file, because not PDF, protein data bank, from a protein data bank file, because that's the one which is accepted by PyRx. So I'm just looking for a certain software which converts the which convert the forms from one type to the other. Yeah, I found this. It's called Open Babel. That's Open Babel graphics user interface. So let's go on. So we our input format we say it's let's go to download. This is the thing which we downloaded that time. So our input format is SDF file. SDF file. So we choose SDF file here, and then we choose the file. Just go to the downloads, and we want this one, and then we open, and then we over here we want this to be in protein data bank. So there are many options, so you choose protein data bank here, and then the output file which we want to, let's just call it Cosmos, and then we save. So then we press the convert over here. So if you go back to the files and go to downloads, here downloads, you see Cosmos is now there. So now we want to see if our compounds can be opened in PyRx. So file load molecule Cosmos, and then open. Now we have our compounds in PyRx ready for docking. So thank you for watching. This is combining compounds for docking, and we have done it. Thank you.